Hello and welcome to this video. It's a pleasure for me to see you here and what we want to talk about today. Today I want to talk with you about supply chain security. What are the key points? What are the tools you can use? How you can protect yourself? And what you can do to integrate this one into your CI or in your software development process. By the way, my name is Sven Ruppert. I'm from Germany and I'm developer advocate for JFrog. And as you can see, I'm here in the woods. I'm in the Swedish woods. I'm here for a hike, let's say 5 to 6 days. And I will take you on 2 journeys. First of all, to the journey here to the Swedish woods. And the second one is to the supply chain security topic. But now it's time to start and let's go. Okay, so let's start with the topic. One topic is supply chain security. Supply chain security is a very, very big topic, and it's not only including software development, it means it's including everything from what materials you need, what are the processes, who's delivering what, third-party components, and so on and so on. So the whole supply chain is under attack right now, and we have different things that are evolving or coming through this supply chain security over the last 1 or 2 years. One thing is the geopolitics is more and more influencing this attacks against the supply chain, because you can see that if you're earlier days, you had just an attack because you're a big company, someone wants to have money from you. Now you're a target because you are a political target. And this is changing the world dramatically, because instead of having individuals, you have now groups or even governments that are attacking you. And if you're inside the supply chain for one of these big companies that are not very friendly seen by other governments, it could be that a government is now attacking you. The same with ransomware. So longer time ago, ransomware was used more or less to encrypt all this stuff, okay, and then you can pay money to get this stuff back. So they have done it just to earn money. But right now, we can see that ransomware attacks are more and more political oriented. It means they never want to see money. They just want to infect your systems, they want to encrypt it, and that's it. So we have different things that are coming more and more. And if we are now thinking about that the big companies spending a lot amount of money, resources and intellectual property and all this stuff to harden their own systems, means that the attackers are now going along the supply chain. So the pressure is not against the final targets anymore. They're going along the supply chain, and it means even if you have a small, medium business size company with, let's say, 20 people, you're delivering to one of these cool companies, then you are under attack because it's the weakest point inside the supply chain. But now we will have a look at the part of the supply chain that is for us important, the software development part. Now we want to talk a little bit about the software version of supply chain security. That means that we are just looking at what is going on here during the time we are coding and working. So I'm stealing now a little bit from this project Salsa. And project Salsa is an open source project from the Linux Foundation. I will explain it a little bit later what's it. But I have here this picture, what I'm pushing here somewhere in the screen, and it describes a typical software supply chain for software developers. So you have, for example, common attacks against it. If you have source code, make sure that you have always code reviews so that nobody can sneak in with malicious code. Then this code is going to this source code version system, a Git server or something like this. How to harden this? Well, you have to make sure that an administrator will close your ports, maintain it, and the administrative rights are just limited to the person that needs it. That's a good thing. Then the source code will be grabbed by the CI environment. What couldn't happen here? Instead of compromising the source code on the, this part of the server, the build infrastructure could be compromised, or you can have something like fetching the original source code and overlaying with external source code. So there is a very common attack. Then the build infrastructure itself, what can you do? You have to harden it. Again, it's part of administrative things and so on and so on. And then the binaries will push to some kind of repositories. So we are going along from source threads, build threads to dependency threads. Inside this repository where all the dependencies are, or the created binaries, they will be delivered to production. Again, this is a piece of software, and here we need support from administrative rights and so on. So one thing is that all these components between each other should be in some kind of zero trust environment to make sure that nobody can sneak in with this one. On the other side, we have now two things left. If we are focusing what can we do as a software developer. We have source code we are creating that is moved along the pipeline, will be created or will be transformed to binaries, and then we have the binaries we are creating and all dependencies. So this is more or less what we have in our hands. Source code, binaries, and all the rest is something that is infrastructure and secured by infrastructure related topics. I want to talk a little bit about the project where I got this graphic from. It's the project Salsa, SLSA. And this is part of the Linux Foundation. It's an open source project and it's a documentation project. So there is no implementation or whatever. It's really a documentation project. And this documentation project is, organized by individual security experts. Some companies are working through. But the main thing is that they want to collect all the best practices around supply chain security to make it accessible for people that are not directly coming from the security area, so that you can start reading. So we have two main topics in this project. The first topic is the levels. The levels from 0 to 4 will describe how you can improve step by step your supply chain with start using CI environment, using audits, and so on and so on. So if you want to know more about these levels and the project Salsa itself, I have a dedicated YouTube video on my channel in German as well as in English. So there I will go through all these details. But for you, it's important to know there are these different levels, and then you can calibrate yourself where you are and what would be the next logical or good step to increase your security. The other part of this project is a documentation about the common attacks, source threads, build threads, dependency threads, and so on. And then you will have description how this attack is going on, prominent examples of it, what happened, what you can do against it, and so on. So you have these levels and you have the description about this attacks itself. And altogether is a very good documentation to harden your own environment and using this as some kind of guideline. This project itself is currently in alpha state. We are talking here about mid of 2022, but even in this alpha state, the project is really, really good. So I really recommend having a look there and try it out. We spoke about the project Salsa, but there is an implementation. It's a Linux project as well. And this is the project Persia. Persia is in alpha state as well. So JFrog started this decentralized package management, and this is covering exactly the stage from we start building until we are delivering this binary. What's excluded is the security of the source code itself. So it's not helping you to have code reviews or non-compromised source code, but it will start helping you with building this stuff and distributing it. So we have different things here. This project Persia is more or less this decentralized package management system for Maven, Docker, and so on and so on. So what we have is we have this build layer. So we are pushing to one of these peer-to-peer nodes URL where the source code is in a commit reference. Then it will grab this on different nodes, the source code, and start building it locally. After this build is done, they start sharing information about how big is the binary and the fingerprints and all this stuff. And if all they are the same, you can imagine that it's not easy to compromise in a peer-to-peer system exactly the nodes that are randomly selected for this build. So the binary is the self. After this, then the binary will be transported to the distribution layer. And the distribution layer is then the peer-to-peer network where you're requesting exactly this. So we have different things like, for example, external reference binaries are not so secure as inside the Persia network build binaries. We have gateways to Docker Hub and Maven Central as authorized nodes, and so on and so on. So it's a bigger project. It's just right now in the beginning. The first reference implementations are done. So have a look at persia.io, and if you want to know more about it, on my YouTube channel, you will find a video exactly about this project. Okay, now we want to talk a little bit about the four main pillars of security testing and protection. And this is something where we talk about SAST and DUST, IST and RASP. So I want to start with the topic SAST. SAST is something that is a static application security protection. So that means you start scanning all parts of your application, binaries, configuration, source code and all this, but the application is not running. So you can start with SAST immediately with the first line of code. You can analyze it, but what you're missing is a dynamic context because you're in the static semantics of this. But you can scan 100% of this part, so all parts. It's, you have the access. You need access to all components, otherwise you can't scan, but you can scan immediately with the first step. The next thing, if you are not in the static application security context, is the dynamic one. And the dynamic application security testing means that we are now able to run the application. So we need to have something running. It could be a test system, it could be integration, staging, whatever. But if we are running this one, now we're looking from outside like a hacker. This attacks mostly, or this testing is mostly done with the most common vulnerabilities like SQL injection that you try to hack from outside. So you don't need knowledge about the internal technology. You just try to hack the system over the API from outside. The good thing is that you don't need to know about the internal technology. The bad thing is that you are not able to test 100% of the systems. You can just indirectly test the most parts of the system, but mostly it shows that you are not able to scan everything because you are just able to scan everything that's reachable by this API. And then we have the need that something is running and you must be able to address this. So mostly you have this cloud-based providers, or you must be able to provide this attack information by yourself. So this is dynamic application security testing. How to combine both, or how to get rid of the weak parts of the different testing mechanisms. This is called IS, it's interactive application security testing, and this means that you try to do both. You can see it like in security debugging. So you are ramping up the application, you are taking from outside, you're analyzing inside the application what's going on, and then you can start modifying the attack vector. You need the knowledge about the technology, the attack vectors, how to do this, the tool stack, and so on. The big challenge here is that for SAST and DUST you can just buy tools, but for IST you need to know a lot of stuff by yourself. So this is mostly not for the beginners. It's something where you need really trained and skilled people from the security environment so that they are doing something that is useful. Otherwise you are testing something and you think it's secure and it's not. Okay, so IST is something that is the combination of SAST and DUST, but you need high-skilled people to do this by yourself. Now we are coming to the field where we are talking about runtime protection. It's called RASP, Runtime Application Security Protection. And as you can see, it's not testing anymore, it's a protection. And with protection, it means that we are just able to do it on a production environment. So you're not able to do it in fields like in staging or testing environment. You need production. So what's mostly going on here is that you have an agent. This agent is manipulating like a performance tool, the application itself, and try to analyze what's going on into the system. Do we have suspicious, malicious activities and so on. And with machine learning in real time, you try to identify if there's an ongoing attack. And if so, you have two choices: shutting down the system automatically or alerting. So that's all. But having now SAST, DUST, IST and RASP, where should you focus? RASP is just the last thing. It makes no sense to trust only RASP. So it's an additional thing. IST, you need very high skilled and trained people. So mostly it's not right if you want to start. In DUST, you need something that's already running. It's good add-on, but the best thing what I would recommend is start with toolings in static application security testing, because you can start immediately with the first line of code. If you start with SAST, so scanning all this stuff, you can scan different things. You can scan your source code, you can scan configurations, you can scan third-party components. And what should you start scanning? To say the truth, if you're looking at how many lines of code you're writing and how many lines of code you are adding via dependency. In the most project environments, it's in a way that even if you have 100,000 of lines of self-written code, you will have millions of lines inside your dependencies. So inside the application, you have the application and a huge amount of dependencies. Even there, the dependencies are bigger than the source code you're writing. The operating system, you're just writing a few lines of configuration. Rest are dependencies. Docker statement even starts with a from statement, Helm charts, and so on, and so on, and so on. And don't forget the binaries of your CI environment, of your dev tools, and so on. So the whole dev stack is a bunch of binaries as well. So what should you focus on? Source or binaries? Binaries, because these are the low-hanging fruits. So big question is, if we should focus on binaries, where's the best place to store them? And it makes sense to have all binaries in one central place, because then you can use exactly the same scanning mechanism for all layers. So with Artifactory there, we have all these different dependency managers, Maven, NuGet, but Debian as well as Docker and so on. So if you are just collecting binaries for your own project, it's fine. But why not collecting the same or over the same gateway, the binaries for your network infrastructure, Linux servers, and so on and so on. Because then you have the central place where all binaries are, and then you can apply with security rule there, with security scanners. And you need a scanner that is aware of metadata. I will cover this in a few minutes, but the main thing is having one central place, and even if you're building stuff, don't grab it directly from Docker Hub or Maven Central, because then you have no control about what is allowed to be used, fetched, and how many times, what version, and so on and so on. So a single place for binaries where all stuff is coming through. Now the big question, scanning binaries. A lot of companies are saying we are scanning binaries, but what is the biggest difference? The big difference here is that if you have the binary management and the knowledge of all dependency managers, and then you're connecting with a scanner. In our case, it's Artifactory, where all the binaries are, where the metadata is in, and then X-ray is connected to Artifactory. Now we are scanning it. So if you're just scanning one binary, then you can identify what's the binary, but you're missing information like, is there a dependency, transitive dependencies, do we have compiled, test scope, runtime scope, dynamic link, static link, and so on and so on. So a lot of metadata that is missing if you're just looking at binaries, and this is a big difference to a lot of other solutions, and we can focus on the whole tech stack. Maven, NuGet, Linux, Debian repositories, Docker, and so on and so on. So this is a big advantage if you have not only the binary, but as well the metadata available. And this is exactly what we have with Artifactory and X-ray. Next thing, talking about shift left or what's the best place to scan. So we have now the possibilities to have access to the metadata. We have the possibility to scan binaries, but what is a good place to scan? It could be, for example, the CI environment. The CI environment is a security gateway for everything. So shift left into the CI means that you are scanning with every build, with every run, and so on and so on. That's necessary. There's a good place to scan for security reasons, or vulnerabilities, malicious packages, and all this stuff. And this is more or less a machine gateway. But is this exactly the place where you should start with scanning? Is this a place that is the earliest place that makes sense to scan for vulnerabilities and compliance issues? I'm not sure about it, because the CI environment is somewhere along the supply chain, somewhere along this production environment, and we have a bunch of other places where it makes sense to scan as well. So I want to go a little bit into the history, and then you will understand why the CI environment should not be the only part where you start scanning for security and vulnerabilities, so security issues. It's called the SolarWinds hack. I'm not going into all details of the SolarWinds hack, but the main thing is that this company that's creating this Orion platform, having 300,000 customers, and every customer is managing the network infrastructure with this tool, and they have a CI environment to build their product, and they have this automatic update cycle, so that with every new release it's automatically pushed to all the customers and so on. What happened? An hacker group broke into this system and they're not changing or modifying or stealing data or whatever. They went straight to the CI environment and modified the CI environment. And the CI environment then built with every cycle a compromised binary. This compromised binary was then delivered via this automatic updates to all these customers. So after this was done, it took 1 or 3 days, just a few days, and they infected over 15,000 customers. 15,000 customers means not 15,000 servers. No, they mean 15,000 networks. And 15,000 networks infected is a huge thing that even the US president, Mr. Biden, took this as something to say, okay, we have to change something. I will come to this a little bit later, but what does it mean for us? For us, it means we have now 2 attacks. We have the attacks, or we have to protect ourselves that we are not consuming malicious or vulnerable stuff. And we have to make sure that we are not pushing this stuff out, so that we are not distributing it. And these 2 different ways we have to protect means that we should be aware of all these security-related topics, not only inside the CI environment. We have to go a few steps earlier and start with this. But now, let's talk a little bit around this SolarWinds hack and how it's affected our way of developing. Okay, now, what happened after this SolarWinds hack? So, Mr. Biden had this executive order of cybersecurity, and it means that every software that is operated, run, owned, or whatever used by the US government must fulfill this requirement of an SBOM. An SBOM itself is a software bill of material. It means the full list of all ingredients that are used to build this binary. Practical, it means if you have a binary and you have all dependencies, and then you need a list of all dependencies with version, name, fingerprint, so that you have the fullest. We know this at JFrog since a long time. That's important not only after the SolarWinds hack, but we called it build info. Build info is more or less a superset of SBOM because you can generate this SBOM out of it. It's just a part, this SBOM, but the build info, you will find it inside the platform near the Artifactory, the repositories. It's more or less for every binary that you are creating, you're collecting information like environment variables, dependencies, whatever, date, time, agent name, all this stuff, okay? So this information is pushed and stored together with the binary inside Artifactory, so you have the whole context of this creation for this binary, and that means later you have some post-mortem analysis possibilities so that you can identify, oh, all builds on agent 3 is something different. You can have diffs and so on and so on. The good thing is that not only the immutable information is there, you have this actual vulnerability information as well. So if you built yesterday a binary and this binary is passing to production, and tomorrow you know there is a vulnerability because the vulnerability database just had an update, so we know it now, then you can see there, oh, here's a vulnerability, it's affecting us, this binary is used in this Helm chart, in this production environment, whatever. Without scanning production, you have this information and you're never building binaries twice. This is the build info, a superset of SBOM. If the CI environment is not the earliest possible thing, so what should be the next one? What I can recommend is, for example, use your IDE. So inside your IDE, you have the possibility to scan all dependencies as well. And this is done by the IDE plugin. The IDE plugin itself is free from JFrog, and you can integrate in IntelliJ, VS Code, Eclipse, and so on. And then you're connecting with this IDE plugin to your Artifactory and X-Ray instance. What happened is that if you're, for example, adding the first dependency to your POM file, then this information will be transferred to X-Ray. X-Ray will give you the whole dependency tree together with the vulnerability information. So you will have straight after adding a dependency all the knowledge about transitive dependencies, vulnerabilities, possible fixed versions, and so on and so on. And this information will include, for example, references to CVEs and all the other stuff that you need to decide if this one is critical for you. But this is way earlier than a complaining CI environment. Now we have this IDE plugin, but there are several ways to get to this information as well. And one is a command line interface. So even if you have no IDE started so far, you can use a command line interface to scan the project. So you cloning a Git repository, going into this repository and start JFrog audit, and then you will get a list of all vulnerabilities scanned. And the scan is based on the project infrastructure. So if there's a POM XML, it will give you all the things, and or some other dependency manager. So it will detect the dependency manager. So the main thing is that you can now scan on command line projects, but on the other side you can scan binaries as well. So if you have local created Docker image, one thing what you can do is you can use the Docker plugin, so Docker desktop plugin, so that you're scanning the self-created Docker image there, or you can export this Docker image so that you have this tar or this archive what you created, and then scanning this one. You can do it with jar, with Docker images, with whatever. So you can scan this, and then you will get the full list of all vulnerabilities, and this report you can push into the section on-demand scanning. On-demand scanning means that this scan will be stored inside Artifactory, and you can share this information with your colleagues so that you can work on this to improve this Docker image and so on. The good thing here is that you can create all this stuff without polluting the CI environment or using resource there, because you're grabbing the stuff, building it, scanning it locally, pushing the report to this central place where you can have this as an audit reference or whatever. And then you can work with the full flexibility what you need before you're using resources inside the CI environment, or stuff is bleeding inside the repositories you want to hold clean. So CLI and on-demand scanning is cool stuff because you can do it straight during your prototyping. If you're scanning for vulnerabilities, you will find one thing quite fast and often, that is in CVSS core. So I'm not going into all details what CVSS core is, because on my YouTube channel you will find different videos about CVSS metrics and how to use it within CVSS calculator to adjust this to your environmental metrics, or with environmental metrics to your environment. But the CVSS values, this is something you should be aware of. And inside the JFrog platform, you will find not only the CVSS values, CVSS 2 or 3.1, you will find the basic metrics as well. So you have two things you should check out. If there's a CVE for vulnerability, check out that you get additional information. So if you're clicking inside the platform on this vulnerability, you will get mitigation and remediation information, you will get reference documentation and all this stuff. And you can use this CVE to search inside Google, for example, for additional information. On the other side, you will get this CVSS value and the basic metrics. And the basic metrics, in short words, is more or less the worst case description of this vulnerability. And there you can see if this is important for you. For example, if this is a high CVSS value, because if this the vulnerability could be misused or could be applied over a public network if connected, but your system is air-gapped, then you can adjust this. But this is something that you should start reading, this basic metrics, and then transfer it or transform it with environmental metrics. I have a dedicated talk about using the CVSS calculator with this environmental metrics to scale the CVSS values for your needs. It's a little bit too much for this talk, but have this in mind that you have all this information. So wherever you're scanning, have a look at the CVSS score, have a look if there's a CVE number to get more information, and decide if this vulnerability is critical for you, yes or no. Okay, finally I found my place for tonight. Perfect. So it was a long hike, definitely a long hike here in the Swedish woods, but I found this half island and there's a perfect place to swim a bit, and there I will have my camp. I will build up there my camp for tonight, and that's it. But we had a good talk about DevSecOps, about dust, Rasp and all this stuff, about toolings and what you can do. And by the way, if you want to try out, you have different possibilities. First of all, if you want to contact me, use Twitter, LinkedIn. Don't use email, it's a disaster. If you want to have more like this, check out my YouTube channel. I have a German one, I have an English one. Make sure that you are selecting the right one for you. And then you will find a bunch of this outdoor style IT related cybersecurity stuff that's perfect. Otherwise, well, webinars, workshops, if you want to have hands-on, they're for free. Go to JFrog under webinars and then you can find a webinar. You can register for a workshop, and then we both can have hands-on on this cybersecurity stuff. Otherwise, whatever day and time you're watching this, have a nice day, have a rest of your day, relax, whatever is necessary. I will do the same. For me, the day is done. That's the last recording for today. I will place my stuff there. Well, enjoy the sunset, and that's it for today. So stay safe and see you.